Hey, welcome to your Daily Dose of Duds. This is day 1 of 11.9a. We're going to be looking at volume of prisms today, rectangular prisms to be more specific. Got 3 things on the agenda. First of all, you should have watched 11.9a and completed the pause problems, the ticket problems. If you haven't done that, why don't you go and do that and then come on back here and finish up. The second thing, we'll be doing a review, and we're going to do about 12 different problems in 3 different little sets here of problems, and then you'll just need to upload your video and your DDD work today. So you put your review on the top of the page, put your other practice problems on the bottom. Pretty straightforward and easy. Let's start with the review. Go ahead and take about 5 minutes max working these, and I'll go over them with you. All right. First one here, well, if we use pi r, the radius is 9, so 3.14 times 9 times 9 will give us 254.34 on the area. That would be centimeters squared. Circumference is just d pi, so it's going to be 18 times 3.14. Got 56.52. That's centimeters. Over here in this irregular shape, well, we can divide it into 2 rectangles. I divided it right here. 6 times 4 gives you 24 in this rectangle. If this measurement up here is 6, that means that this one here has to be 4, and because this one is 2, so a little subtraction there gave me that measure. 4 times 3 is 12, so the areas of the 2 rectangles are 24 and 12. Add that up and you got 36 centimeters squared. A little chapter 5 action here, dividing mixed numbers and fractions. First of all, make this into an improper fraction. That becomes 8/5, and then do the old keep, change, flip. We keep it, we change the sign, we flip it. Multiply straight across, we've got 64/25, and reduce that, we've got 2 and 14/25. Another irregular area problem here. Well, divide this, multiply these 2 together to get the area of this large rectangle at 160. Here you got a triangle that has a base of 4 and a height of 7. 4 times 7 is 28. It's a triangle, so you got to divide it by 2. That leaves you with 14. Add those 2 together, and the sum is 184 inches squared. All right, today we're going to be doing the volume of rectangular prism. We can take a look at this one here. We can find out that it's 1, 2, 3, 4, 5. It's 5 wide, and it's 3 deep, and it looks like it's 2 high. So we've got 5 times 3 gives us this base up here of 15, and then it's 2 layers high. It's like a layer cake. So you have to multiply that 15 times 2, which equals 30. Now, I know that may be a little bit unusual way of explaining it, where you find the base and you multiply it by the height, but that's the way I want you to get to today. We're going to go back to the standard way that I was taught, and I'll show you that as well. But our goal is to get to base times height. This is where we're going. Here's the first 3 problems. Here, I'll do the first one for you, and then I'll have you try a couple. This one here, I'll just do this one here. We've got the length times width times the height. We need to figure out what those are. They didn't give it to us, so we just have to count them. So it's 5 cubes this way. It's 3 cubes deep. It's 2 cubes high. 5 times 3 is 15 times 2 gives me 30 units cubed on this one here. You go ahead and grab a calculator and multiply those numbers together and get the answers to those 2. And jot them down. All right, well, this one would have been 3.5 times 3.5 times 3.5. It's a cube. Should have had 42.875 inches cubed. Down here, should have had 37.125 feet squared. 5.5 times 3 times 2 1/4. Alrighty. Go ahead and take a look at this next thing. Now, I want to talk a little bit about little b, little base, and big B, big base. Little b, a small b, is talking about a one-dimensional base, like on a triangle. These are all bases, all these yellow lines here. And on a trapezoid, the top and the bottom, we call them the bases. They're one-dimensional. A big base is two-dimensional. It has an area in units squared or inches squared or something. All of these are all two-dimensional. So that's where we want to go. We want to get you to be thinking about the base of a shape times the height to get the volume, because it's going to be most useful when you move in to finding areas of pyramids, of cones, and other types of prisms. Pyramids. So here's a base centimeter squared versus base centimeters cubed. So right here, I'm just going to take this guy off here. You can kind of see how this top one here, these would be centimeters squared. It's two-dimensional. If I grab this guy and I move it up here, and all of a sudden it becomes base centimeters cubed because now we have that third dimension. Okay, it's 5 by 4 by 1. Here, it's just 5 times 4, two-dimensional. Here's that third dimension. That's where the big B is, when we have a two-dimensional base and we multiply it by the height. So in this case here, we'd have 5 times 4. You can think about there's the base, and we have 1, 2, 3, 4 layers of that base. So 5 times 4 is 20. You could add all those bases together or multiply them by 4 different layers. You can have 80 centimeters cubed. Now, yes, you could have taken 5 times 4 times 4. I'm going to keep saying this over and over. It's the same thing. But we want you to start thinking big B, big base times the height. Let's take a look at some problems here. And I've done one here, and I'm going to have you do 3. So I want you to think about, on this rectangular prism, think about this being the base, and do these first and figure out what the area of that blue rectangle would be. Very good. It's 30. Right here, there's the base. That's 6 times 5 gives you the 30. Now we just multiply it by the height, which is 8. 30 times 8 is going to give us 3 times 8 is 24. Take that, add the 0. We've got 240. Sorry, I got a whole bunch of alarms popping up here. All right. You go ahead and try these 3 here. Find the area of the base, and then the area of the volume of the rectangle. And I put the bases. I noticed that in a rectangular prism, depending upon how you lay the figure down, you can think of different types of bases. So maybe I'm thinking about this end as being the base, or the front as being the base, or the top as being the base. It doesn't matter because it's a prism. We can set it. The way we orientate that determines what the base is. So go ahead. All right. We use big base times height. You should have had these answers for those 3 problems. 84 meters cubed, 630 centimeters cubed, and 16.2 feet cubed. All right, thinking about big base times height, I'd like you to try these problems right here for your independent practice. I told you it wouldn't be a difficult lesson. Put myself right there so you can see all the problems. And go ahead and pause, and I'll let you run through those. Okay, let's just drop a screen in here and take a look at the answers to those questions. 63 centimeters cubed for the first one, 300 inches cubed for the second, 96 meters cubed for the third, 180 millimeters cubed for the fourth one, 186, I'm going to double check that and make that just a touch bigger, 186.2 inches cubed, and then 194.4 centimeters cubed for that last one. All right, that's going to wrap it up for the day. Make sure you upload the answers to those 12 problems we've just done, along with your video and pause problems, to the 11.9a video assignment. All right, thanks. See you tomorrow.